the graph of elasticity, or you call it stress strain graph. The diagram represents the stress strain graph of a loaded wire. Which of these statements is correct? So we are going to check this option, not the one that is correct. But before we check the option, not the correct one, let us first analyze the graph of stress strain. So from point 0 here to I, we call it what? Elastic limit. Elastic limit. The reason we call it elastic limit is between this point 0 to this place of I. If you any length you stretch the wire or the spring is going to return to its original length when the load has been removed. That means the string has its elasticity. And again, what to know about this point of elastic limit is that the extension is proportional. You know, Hooke's law says that the force applied is directly proportional to the extension. So at point I, the more force you apply, the more the extension, and when the force is released, the spring or wire returns to its original length. So that at point I is where Hooke's law is obeyed. Then we enter point J. At this point J, we call it the yield point, the yielding point or the yield point. So a yield point means at point J, you have stretched the wire to the point that it now yields. It doesn't return again. You now stretch the wire and it refuses to return again. But you see, between I and J, this point between I and that's just immediately after I, what happens there is that when you stretch the string, it does not lose its elasticity, but it won't be proportional again. Take for instance, if the original length of the wire was 2 meters and its elasticity can take it to 3 meters, extra 1 meter. If the elastic limit can, that's plus 1 meter, can take it to 3 meters. Then if you bypass that 3 meters, that's you are approaching the yield point. At that point, when you release the load, when you release the string, it doesn't return to 2 meters again. It might return to 2.5 meters, 2.1 meter. That means you stretched it beyond its elastic limit, which is I. So elastic limit is where Hooke's law is obeyed, where the force is proportionate to the extension, and where when you release the load, the wire returns to its original length. Then beyond I, the wire doesn't return to its original length. Then at point J, we call it the yield point. At that point, the wire doesn't return at all. You have stretched it beyond its elastic limit and it doesn't even return again. It just stayed there. Then when you go beyond J, approaching K, we call K maximum stress. Maximum stress. That means after J, where the wire doesn't return to its original, doesn't even return again, and you continue to stretch it. At this point, the wire will still extend, or the spring will still extend, but at the same time, it's not extending proportionately. You just extra force may make it just extend rapidly like this. That's what this sharp point means. That is small, the extra force that you now add now extend it so improportionately. It doesn't go in proportion, just a small force and it goes so high. So that's what K is, maximum stress. So at that point K, you have extended the wire or spring to its maximum stress. That's the maximum stress it can handle. Stress is another word for pressure. But the reason we call it stress is the pressure that happens within a material. But pressure on its own is when you are measuring the amount of force applied on per unit area of any material. Okay, that's okay. We continue. So at K is maximum stress. That means you have reached the maximum length that material can go, and anything beyond that means breaking. It's going to break. It's going to cut. It's going to shatter. So at L is what we call the breaking point. That means if you go beyond K, the thing will break. Breaking point. So I is the elastic limit. J means yield point where it doesn't return again. It doesn't even return again. And then K means maximum stress. That's the maximum length that string or wire can go. Then L means it will break down. So option A says at K wire breaks. No, the wire doesn't break at K. At K, the wire has reached its maximum length, but it doesn't break. But you can't extend it beyond that. If you try to extend it beyond that, it breaks. So A is out of option. B says L is the elastic limit. L cannot be the elastic limit. L is the breaking point, the point where the wire breaks. Then C says J is the elastic limit. No, J is not the elastic. J is the yield point. J is that point where the material doesn't return again. It has lost its elasticity. You understand? It has lost its elasticity. So this says beyond J, the wire loses elasticity, which is very correct. J is its yield point, meaning it doesn't return to its original length. It doesn't return again. Its elasticity has gone. So beyond J, the elasticity of that material is completely gone. It will not return. There's no elasticity in it again. So if you keep extending, you just so D is the answer to that question. So the question can come anywhere. They might ask you what happens at I or what happens at K, things like that. So subscribe to the channel, and for online classes in real time, you join my WhatsApp group and book a session. Thank you.